In this video, we're going to be talking about parallel lines, what it means to be a parallel line, and how to determine if lines are parallel. So, can you recognize the parallel lines out of the 6 examples I have here? Did you choose these ones? If you did, you're right. What does it mean for lines to be parallel? It means that they never intersect. And in order for that to happen, they have to change at the same rate, which means that they have the same slopes too. So we're going to go ahead and we're going to look at an example of some graphed lines, and we're going to determine which ones are parallel. So here we have a red line, a blue line, and a green line. And we're going to find the slope for each of these lines. So our blue line is line A, our red line is line B, and our green line is line C. So we're going to find the slopes of each of those lines. It gave us the 2 points for each line, so we can calculate it if we want. But because it gave us a graph, we can also count it. So we'll start with our blue line, and we see that we're going to rise 1, 2, 3. So we're going to rise 3, and we're going to run 1. So here we're going to have a slope of 3. Let's take a look at line B. So from line B, we're going to go from this point to this point. So we're going to rise 1, 2, 3, 4, and we're going to run 1, which gives us a slope of 4. For line C, it also gave us 2 points. So we're going to count that 1, 2, 3, 4, rise 4, and we're going to run 1. So here we have a slope of 4 as well. And so we can see that these 2 lines right here are going to be parallel. So we can say that lines B and C are parallel. And we know that because they have the same slopes. Let's do another type of an example where maybe we don't have a graph, but instead the equation of lines. So here we're going to determine which of these lines, if any of them, are parallel, and we're going to explain why. Now, we already talked about how we really want the slopes to be the same. So in order for that to happen, the easiest way to do that is to put all of the equations in slope-intercept form, which you might remember is y equals mx plus b, where the m is our slope. So we're going to go ahead and do that to each of our 3 lines now. So for line A, we're going to add x to both sides, which then gives us 5y equals x plus 4. Then we'll divide everything by 5 to get y equals x over 5 plus 4 over 5, which can also be written as y equals 1 over 5x plus 4 over 5. And so here we have line A, right? So there's line A. Now let's do that to line B. For line B, it looks like all we need to do is to divide everything by 5. And so we have y equals x over 5 plus 7 over 5. And we know we can rewrite this as y equals 1 over 5 times x plus 7 over 5. So there's line B. So now we'll get line C in slope-intercept form. To do that, we'll add 2x to both sides, which will give us 5y equals 2x plus 5. Then we'll divide everything by 5, which will give us y equals 2 over 5x plus 1. And that is our line C. So in order to compare them, we need to look at their slopes. We need to look at their m's. So here in line A, we see that we have a slope of 1 over 5. In line B, we see that we have a slope of 1 over 5. And in line C, we see that we have a slope of 2 over 5. And so we're able to see that because line A and line B have matching slopes, because they're the same, we're able to say that line A and line B are parallel, and it asks us to explain. So because they have the same slopes, and we have our answer, and we're finished. So we can determine if lines are parallel by finding their slopes and then comparing them.